Hello and welcome to my channel Physics with Fun. Here we will discuss about the very basic concepts of the physics. In today's video we will learn about an important topic of vectors, which is parallelogram law of vector addition. Imagine a boat is crossing a river from one bank to another. It's moving in the direction perpendicular to the flow of the river. The boat will not reach to the point P at the bank of the river, but the boat will reach the bank somewhere in the right side of this point P. We know that the motion of the boat is also influenced by the velocity of the river along with the velocity of the boat's engine. So the boat actually travels with a different velocity, which is the resultant of these two velocities. If vector v1 represents the velocity of boat's engine and v2 represents the velocity of the river, then the resultant boat's velocity v3 will be the vector sum of these two velocities. Let's find out these velocities. Let's say this arrow represents vector v1, the velocity of the boat's engine. We know the reverse velocity is perpendicular to v1, so let this arrow represent the reverse velocities v2. Now we know that the vector v3, which is the boat's actually velocity, will be somewhere in between these two vectors, but how can we find it accurately? Actually, to find the vector v3 precisely, there is a law of vector addition called parallelogram law of vector addition. Now, let us suppose that we have a parallelogram and the two adjacent sides of it represent the two vectors a and b in magnitude and direction like this. Then the sum of the vectors a and b is represented in magnitude and direction by the diagonal of the parallelogram through the common point. This is known as the parallelogram law of vector addition. Now let's get back to our example. Can you apply this law here to find the boat's actual velocity v3? For this, let's draw a line segment parallel to the vector v1 here and similarly a line segment parallel to vector v2 here. So since v1 and v2 are perpendicular to each other, we get a rectangle here. Now, according to the parallelogram law of vector addition, this diagonal will represent the vector v3. We can also find the magnitude and the direction of the vector v3 by using the geometric properties of this rectangle. So, in this way, we can apply this law to find the vector sum of two vectors. Now, suppose we are given these two vectors c and d whose initial points are not the same. Can you find their vector sum? For this, we will just move one of the vectors parallelly without affecting its magnitude and direction such that the initial points for both the vectors coincides. If we move vector d, then we will get this. Now we draw two lines parallel to vector c and d to form a parallelogram. Then, according to the parallelogram law of vector addition, this diagonal will represent the sum of the vectors c and d. But wait, in the previous video we saw that the sum of the two vectors is given by the triangle law of vector addition. Here, according to this law, we move vector d such that its initial point coincides with the terminal point like this. So, we see that these 3 points A, B and C will form a triangle. Now, the third side of the triangle in the opposite order, then these two represent the vector sum of the vectors. Thus, we have two laws of addition. Now here is a question, which one is to follow find the vector sum? Actually, both the laws gives us the same resultant vectors. These two laws are equivalent to each other. So this is all about our concept, the parallelogram law of factor addition. So like, share and subscribe the channel to stay updated and to keep learning such interesting videos. Thanks for watching.